Welcome to a Math 60 lecture video, section 3.4. This is more about rates of change and slope. So we are going to talk about these rates of change and slope using our 4 ways to represent mathematical ideas. Because it's very important that you are able to find something as foundational to mathematics as the slope or the rate of change. It's important to be able to find it where with all these different representations. So let's start with symbols. If I have a linear equation, which is usually written in slope-intercept form, like y equals mx plus b is our general equation, but let's use as an example. Let's see. Let's say y equals 3x minus 7. And then the slope, which is the rate of change, is 3. It's the number that multiplies by the x. My slopes can be simple positive numbers like 3. They can be fractions like 1/7 x plus 2. The slope here is 1/7. And what that means is when x increases by 7, y increases by 1. Slopes can be negative. You could have y equals negative 5x plus 3. And what this means is when x increases by 1, y decreases by 5. The reason I say x is increasing by 1 is I can always write the minus 5 as minus 5 over 1x. And there's the change in x by 1, change in y decreasing by 5. You can have decimals. You can have 0.00316 x minus 1.725, right? And that says when x changes by 1, y increases by 0.00316. You can even have a slope that equals 0, which would be y equals 0 times x plus 2, but 0 times x is 0, so we would just write y equals 2. This is still a line, but it has no slope. It says no matter what x changes by, y never changes. It's always 2. So that's how you find the slope from symbols. Let's do words next. So the slope is the change in y, or the change in the output, divided by the change in x, which is the input. So you could say something like every additional ice cream costs $3. Every time my input, the number of ice cream cones or ice creams goes up by 1, the total cost goes up by 3. So the slope here is $3 per ice cream. You could say something like, let's see, my car is worth $5,000. Every 2 years, the value decreases by $800. So in this case, the slope would be $800 less in value per 2 years, which if we switch to our numerical, we might say is minus 800 over 2 or minus $400 per year. That's how you pull the slope out of your words representation. Now let's do numbers. There's two versions of this. One is a table. So let's look at a table X, Y. And X is going to increase by 1 each time. And Y, maybe it starts at 5. And then it goes to 3, and then 2, 1, and then -1. So the slope, which is the change in Y divided by the change in X, I find that by looking at what is my change in X. Oh, it goes up by 1. And what is my change in Y? It goes down by 2. So the slope is the change in Y, which is -2, over the change in X, which is 1. And we'll often write that as -2. You could also have a table XY. Oh, it's a good idea to check and say when it goes up by 1, it goes down by 2 again. Okay, good. So I have a nice consistent slope. That's what we want to see, is that every time X goes up by 1, Y goes down by 2. Now you could have a table where your change in X is not just 1. This change in X is actually going up 4, and this change in Y is actually going down 20. How do I know it's 20? Because -13 minus 7 is -20. And 6 minus 2 is 4. So the change in Y -20 over the change in X, 4, would write that as -5. That's the slope. And this idea leads us to the coordinate points. A line goes through the points 1, 5 and 4, 12. The slope, which is the change in Y over the change in X. Well, the change in Y is how far it went between 12 and 5. And the change in X is how far it went between 4 and 1. And we often write that as y2 minus y1, because here's my y2, which is 12, and my y1 is 5. And I divide that by x2 minus x1, which is 7 over 3. That's my slope. So you can always find a line that goes through 2 points by subtracting the y outputs, subtracting the x outputs, or the x inputs, and then dividing. But you can also build a table if you prefer. I can take these points and I can put it into a table. I'll squeeze it in here. I have 1 and 5 and 4 and 12. This goes up 3, that goes up 7, and sure enough, the slope is 7/3. All right, let's look at finding slope from a graph. So pictures. So let's take a line that goes like this. It should be there. One, two, three, four. And I want to find the slope of this line. Well, the slope is the change in y over the change in x. And so what I do is I walk out a certain amount of x's, like let's go this far. And then let's walk out a certain number of y's. So we often refer to the change in x as the run and the change in y as the rise. So another way to think about slope is rise over run. My run was 2 because I went from 0 to 2. And my rise is 1 because I went from 1 to 2. And so that's my slope. Let's do another example. Let's start here. And it's going to plunge down pretty quickly. Fast enough that I'm not really going to get to draw much about it. But this point right here is 0, 3, and this point right here is 1, -2. So again, I'm going to think about my rise over run. Let's run one step this way, and then the rise is actually a negative. So the run is here and the rise is there. Slope, which is rise over run. Well, the rise goes from 3 down to -2. So that rise actually goes down 5. And the run is 1. And so the slope is -5. So those are the 4 ways to find your slope. We talked about the symbols first, where you can just read it off. The words, where you have to ask yourself, how is the output changing and how is the input changing? The numbers, where you do some subtraction and division, and then the pictures, where you look at the rise over the run. This is a short video because section 3.3 and 3.4 are kind of squished together. And thanks for watching.